So with the surface created now, we have the possibility of doing things like changing my view to, let's say, a southeast isometric. And if I change my shade mode to something like realistic, but now we have the 3D representation of our OLS and our obstacles, and we can zoom in and we can look at things like our individual points or our wooded mesh surface here and see whether or not there are visual indicators that surfaces have penetration for the obstacle limitation. Now, we haven't run an analysis yet. There is a separate command to do that, so it can be a little hard to determine at this point. There may be a little bit of a tell on here that there's some penetrations based on the color for the obstacle changing at some point beneath the surface and above the surface height. But at this point, we've only built the surface. We haven't done any analysis. So the next step for that, we're just going to change back to a better performing shade mode for manipulating our view. So that's using a 2D wireframe. We'll go back to a plan view and we will evaluate the obstacle intersections now. So this is the test of checking for penetrations to the surface. So when we evaluate the obstacles, we need to determine, do we want a text-based label to be placed at each obstacle, giving me textual information for the obstacle height, the surface height for the OLS, the terrain height, the height between the terrain and the surface, and the delta penetration that the obstacle may be through the surface. So as a text basis is where I'll start. I have no other surfaces defined, so we'll only base this against ARP. The SkySAFE mesh or the Civil 3D tint surfaces would become available as those objects get added to the model, which we'll build in. If we like, we could automatically save the results in a CSV file that will go back to our project directory, but we're going to leave this just as in the drawing right now. And we'll see that when obstacles are spaced fairly far apart, the text-based labels are not a big issue. But when we do have them in a tight area, they can become a little difficult to read. So a tabulated format may be better. And then when it's done, I'm going to have some labels that will be drawn for each obstacle that has an issue that I might be looking at. So here in this case, obstacle 9 has a height of 545 meters above sea level. The height of the obstacle limitation surface at this object is 474.12 meters. Hence, we have a penetration of 70.88 meters. The max height above the ARP is 136.12 meters. But that doesn't really tell me too much about what the terrain elevation is here at the base of this obstacle. It's drawn from Z0 all the way up to 545 meters. So it does give me a reference back to the ARP. It is telling me it's in the approach path for runway 0220. If I come down to the wooded mesh here, I think we could agree that this is going to be near impossible to read based on the cluster of elements that we may have. So what we may prefer to do at this point is to change our obstacle intersection evaluation to use a tabulated format rather than text-based. And that will prompt me to specify a point on screen to insert a table that will be an embedded Excel spreadsheet. I can do some formatting of it in the drawing, and I can export and link it to the external data if I'd like, and leave it live linked. But at this point, we're generating it and embedding the table. But this will give me quantifiable values now that tell me what delta penetrations are easily distinguishable in the table. And being a spreadsheet, and certainly exporting it, you could take it out to Excel outside of CAD, and you could do things like sorting by the descending values to give the largest penetrations at the top, and then start working your way down the list.